There's a huge pressure at the end of the month to get that work out there. If you can release every day, well, screw it, I'll take an extra day, no one really cares that much. The deadlines become much more flexible. So you no longer have these deadlines. If you want to take a little bit extra time to write an extra test or get the extra polish in there or get someone else to review the code. I love code reviews because we were dealing with $1 billion order system and you can really screw the company. You want to get another person, that's like one of the finance people in to have a look and check your logic. Great, take an extra day. It doesn't matter, and a day late is not that bad. Okay. A month late is bad. So this is a major advantage for developers as well. Now sysadmins can be a bit funny about this. Sysadmins until quite recently were very much hand building things. Now we've changed a lot in that time. Puppet and Chef and so on have really changed the idea of how we deploy things. Obviously you have to work at scale now. We used to have a handful of perfect little machines that we hand manage. Now we have to have thousands of VMs, and if they break down, we just shoot them. So I think that the world's changing there, but there's one major way you can get the admins on your side, other than tell them that they get to play with some new cool toys like Ansible and so on. But there's a major advantage is when something breaks, you know who did it, and you can go and scream at them. Speaking as a sysadmin, that doesn't happen very often. One of my finest, most enjoyable moments in Atlassian was not long after I joined, and I was the only sysadmin in the company. And the network was terrible, it was like an old ADSL connection, it had been built by developers who thought that networking involved plugging something in the wall, and that's the end of that. But eventually the net was really weird, and one day I came in and I managed to nail down the person who was using BitTorrent on my network. And I was so happy because I could just finally get someone. I didn't even do it, wasn't that bad to him. It's like I was just so happy to have finally, got someone to shout at. I didn't have shouting very much. So sysadmins love this. They love having someone to blame. They love having to be able to say, no, you screwed up, and there's no question about that. And this feature-based releases gives you that for the very simple reason. Think of a theoretical idea. A bunch of changes go out on Monday mornings. That's your release window. So whatever work was done during the week. Alice made a change to the database schema. Bob added a new Ajax endpoint. And Charles made a modification to the UI to call a different Ajax endpoint. Now, that release goes out and the database spikes through the roof. Massive traffic. This guy is going crazy. who was at fault? We don't know. We have to roll back and then maybe have a git bisect or something to break apart, do separate testing, go to staging, make sure, find out, what happened and who's to blame. However, if each one of those changes went out separately during the week, and if you're smart, if when you do make that change, that release, and it goes out there, you also put a marker into all of your graphs, your disk, your I/O, your network, everything, and you say a release happened at this point, and then you can see the spike goes through the roof. You can nail down exactly who did it, and you can go shout at them, and you'll be entirely justified. So this is a very powerful tool for sysadmins. If you can break down every individual change to the smallest piece, you can identify which changes are breaking the system, which ones are causing regressions in the database or disk or CPU or whatever. It's a very, very powerful idea. So then this is, again, I'm now talking about, why we do this, how we do it, more why. But let's go into a little bit of how, but starting at the top level. So I'll talk about a little bit about how you actually adopt this. Now, as with Agile, every team, every organization is different. And in the case of very agile organizations or teams, every release, every sprint is a different situation. You change constantly. That's the whole idea. So I can really only explain at a high level how it works for us. Everyone will have to adjust to their own organization and their own needs. But this is a very basic overview of the process. And this, I think, applies to most people. I think this is good advice in general. One is you must track the work you're doing. If you're going to be doing a lot of releases, you're going to have to be able to identify what code is going out and where it's going out at any point. You branch, continuously test, obviously. You use pull requests for code review and for management. We have a staging deploy server, and then we promote up from staging into production. Now I'll take you through each one of these in turn and explain the purpose behind it. So the first step is to track your requests. Now, when I say requests, I don't mean to be in bugs, I mean everything. Every change is a bug. Now, if it's a big change, it might get broken up into smaller subtasks or into epics or whatever. Doesn't matter. Every single change that you make needs to have some kind of number or identifier attached to it. Now, obviously, from our point of view, we use Jira, and that gives us some powerful workflows I'll go into. I'll try not to turn it into a marketing talk. I'm going to really talk about Atlassian stuff because that's all I know. But we track every single request in Jira, but you can use whatever tool you want. Now, having given every change we're going to make a unique identifier through the bug tracking system, which will track that, you can basically everything you want to go back, you can go back to your Jira, maybe even back to Confluence. You can type Confluence pages in if you want something more complex. You've got identifier, and that travels with that change right through from end to end for reasons I'll explain later. It enables a very powerful workflow. Now, how many people here are using Git or some other distributed version control system? Cool. How many people are using an older version control style, such as Subversion or CVS? So one or two. Anyone not using version control at all? Wow, still out there. This only really works with I say distributed version control system, but a modern version control system, one that handles branching correctly. Subversion does not handle branching correctly. Believe me, I have been down that path. You need something to handle a branching, merging strategy, because every piece of work gets broken off into a separate branch, and it is not merged back to the main stream of development until it is ready to go out. And I'll show you how we identify what ready is. But you isolate your work, you work on it separately, and only when it is guaranteed to not break anything, or as close to guaranteed as you can reasonably get, do you merge on. How do you guarantee that? Well, if you continuously test, continuous integration, you need a tool that will build and run your automated tests. And your automated tests must be extensive. We are very extreme on that team. We start with the unit test, but every change runs all of our acceptance tests, the whole lot. Now, these can take an hour or so. Now, we throw a lot of hardware at this. to do this. Now that's quite expensive, but I'll tell you what's more expensive is developer time. Humans are expensive. Computers, memory, CPUs are cheap. Just get an AWS account and just throw CPUs at the problem if you want to do lots and lots of builds. So we have maybe 20, 30 streams of development going on at any time, all on separate branches. On that branch, every acceptance test is run against every commit. So we are guaranteeing as close as we can that we are not going to break anything at any point. So this means throwing automation at the problem again. Your test must be automated. You must be using some sort of tool that will, every branch will run every single set of tests. Obviously we use Bamboo internally, but really it doesn't matter if you're using something else. It's important you run all your tests because we're going to be doing a lot of these branches, and it's important that they are fixed before they are working before they get merged back. But even then, one thing that I always say, I think people forget, is software is written by humans for humans. This means that humans must be involved in the process at some point. So before you do that final merge, you must get a human involved. Ideally, other people on the team who have knowledge of the particular area you're working on. Because some things are hard to automate away in testing. Say technical debt, algorithms that are blowing up that aren't necessarily optimal, API decisions, getting REST APIs right in a tasteful way is an art form in and of itself. So you get humans in, and we do pull requests. So we use Bitbucket pull requests to say and we can't merge this back until someone's signed off on it. In particular, in our case, Bamboo feeds all of the build results back into Bitbucket for us. So our pull requests have rules associated with them. There must be at least one reviewer ticks off on it, and all of the tests must be passing. So we basically automate the QA process as well. We say we have certain rules that are set inside Bitbucket that say what the criteria under which a merge may occur. But once that's happened, someone signed off on it, the builds are green, you press the merge button, what happens then? So in our case, what happens is it gets merged back onto the main branch. We don't have an elaborate multi-tiered branching system of hotfixes, etc., etc., etc. We basically try and keep it as simple as possible. Our master branch is a release branch, but things are only merged onto the master branch when they are ready to go out. So each merge gets turned into a release. So immediately, once the merge occurs, it triggers a separate build that runs the full release process and automatically pushes it up onto a staging server. Now this is the final level of QA. This is when we say, okay, this is where we're going to get other humans involved. This is where we might get QA involved, or we might get the original customer involved. This is like sort of the user who's asking for a change. You can say, go look at the staging server, tell me if that looks right to you. Because again, by humans, for humans, very important concept that gets forgotten a lot. Then, if it is all signed off by everybody, we promote that up to production. We then do a separate build, we automatically convert what is on staging straight out onto the production server. We have no separation in terms of builds. This means that what's got tested is what goes out there. You don't get it weird, it got built-in staging on the JDK6, but then got built to production on JDK7 and something weird happened. So we always make sure what goes out is what was tested. Talking of going out, that's where I think this often gets left out of these talks, is how do you actually get stuff onto servers? Give that what I call the last mile. Last mile is a term that comes from the telecommunications industry. It's actually really cheap to send data across the Atlantic. It's really expensive to get it up to your doorstep. In particular, using old copper cables and so on, or you have to run new fiber, whatever. That last mile from the exchange up into your house is the most expensive part. And it is the case with production servers, or staging servers as well. How do you get data from your build environment out onto your production or staging systems? This is one that I think is not covered very much. Again, I can only talk a little bit about the process that I went through in choosing a technology to do this. And I was hoping to take you through my reasoning at the time. This is all completely out of date, as in anything in computing is out of date 5 minutes after you've made a decision, but I'll hopefully take you through the process. So the first thing we looked at is using an agent-based system. This was natural for us because our Bamboo systems are agent-based. We did look at using Bamboo agents directly to do deployment, but it didn't really scale. It wasn't designed for it. We needed to find something else that deals with being able to roll things out to multiple servers in parallel and understand the idea of rolling changes, which Bamboo does not do that, nor should it. So one of the main ways to do it is what's called an agent-based system. So what happens is you have a server or a tool on your build system, and it can communicate with agents running on remote servers and say, perform this action on my behalf. And it can sort of send them out in parallel, in series, etc., etc., etc. There are a number of these out there. Let's say Bamboo is one of them, sort of, but it's really a build system. There are other ones like SaltStack. Puppet has something called Collective that you can use to run automated commands. Funk is another one, now largely defunct. And I say Bamboo itself, but it's not really appropriate for it. These are good, but they involve modifying your infrastructure. It means any machine you're going to deploy to must have these tools already on them. By the way, I should segue a little bit here. When you talk to your sysadmins about rolling out software, they're probably going to say something like Puppet or Chef, because they're probably using that now. These are not appropriate tools for deployment. They build the underlying infrastructure. You say to them, I want my infrastructure to look like this. However, how it gets to that state is entirely up to Puppet or Chef. This means we want to be a little bit more fine-grained. We want to say, I want to bring out server 1, bring it out of the cluster, check it, modify it, check it again, then put it back into the cluster and only then go on to the next server. Puppet can't do that. Puppet doesn't really work at that kind of cross-network level. You want a different tool for this. This is where you're looking at these systems that are designed for deliberate, automated, step-by-step, imperative-style changes. So there's agent systems. I have personally looked at some of these, however, it didn't really work for us. It more involved making changes to our infrastructure we really rather not do. However, we already have an agent system out on our servers, and almost certainly out on all your servers as well, which is SSH. It's almost certainly running on the servers anyway. It's encrypted, it has authentication, it has all sorts of lockdowns you can perform to limit what a login system can do. It's very, very powerful. So what we would use that as the agent system. Well, that's a quite common idea. So there are a number of tools out there that use this. You can literally just write a bunch of shell scripts that use SSH and run commands on your behalf, but you're going to basically be reinventing the wheel again. So we have Fabric and Capistrano. However, the tool at the moment that will not work best for us is Ansible. It's somewhere between a programming language and an imperative declarative style system. So it's actually quite good. Sysadmins can understand it. It looks like a script to them. Developers quite like it because it looks like a very simple declarative programming language to them. So we found it to be quite a sweet spot. Both sysadmins and developers were quite happy working with Ansible. So this ultimately was the solution we came up with. We ended up using Ansible over SSH. And this is what we came up with. We use Bamboo. We have a certain agent server that runs the build, runs the full the release build, and then its job is to use Ansible to deploy it out there over SSH. We would basically use keys. We had special users, special keys who had the permission to do the deployment and absolutely nothing else. Those were locked down, and then these agents would be able to push out over Ansible. So this is what the final solution looked like. Deploy out, use SSH, use Ansible to orchestrate things, use SSH, requires nothing special on the remote server because SSH is already running there, and then we use that to do the deployment. Now, I want to segue slightly here and talk about an elephant in the room that a lot of people don't talk about with this as well. If you're continuously deploying, are you going to have continuous downtime as well? This was the reason this project took me something like 9 months to do something which theoretically any effective developer and or sysadmin could knock together in an afternoon. Because if you have a monolithic system, it's basically a single server running, and you're going to be continuously upgrading it, then you're going to have continuous downtime as well. So what we had to do is convert our monolithic system into a clustered, highly available system. And that was the biggest piece of work. But once we did that, we could now have a very elegant way of upgrading things. So what it looked like was we do the deployment, we go off to the load balancer. The load balancer, we use HA proxy. Ansible can talk to that. You can log into the HA proxy server and manipulate it and say, I want to take the server number 1 out of the cluster. So we would do that, the pull out. We would then, Ansible would go off to the server, do the upgrade. Having done the upgrade, it would then check that it's okay, perform a bunch of post-deployment tests, and only then would it look at pulling it back in to the system. Having done that, it would then go off and do the same thing to the next server, and the next one, and so on. So this is why you can't really use Puppet, and you have to use something that is a bit more imperative, that has a concept of it needs to perform action across multiple hosts, and only if that action is completed correctly can it move on to the next step. So, again, this is a very, very important idea that's not really covered quite a lot. Now, this doesn't apply to all things. There are some parts of our systems, we broke that out and turned it into microservices, or not so much microservices, but small separate pieces. Not everything needs to go through this. Generally speaking, it's the front-end systems. The ordering systems needs to have this high availability setup because we don't want to miss the opportunity to take some money. However, some of our back-end systems, what would happen is we had a back-end accounting system. Now, that didn't need to be updated straight away. If now, a few hours later, when the invoice came into our accounting system, that's okay. So what we would do, we'd actually put that onto a queue. We're using Hornet Queue to put all these invoices on the queue, and then we had a server sitting on the end of that queue. We just pull them off and put them into the accounting system. That one we never bothered putting high availability on. We pull that off, well, the queue builds up, and you put it back in there, and the queue just drains empty eventually. So not everything needs to go through the high availability. But all of our front-end systems, the web tier, database tier, all of our ordering transaction systems all have to be high availability. And you need to be aware of what the process is, what's going to happen when you've got multiple versions out there. So you look at things like blue-green deployments and so on. We built our system so that we rarely have ever modified the database, so that would not be too much of a problem for us. But you need to think in terms of high availability, which means thinking in parallel and thinking about how changes occur. And the last thing I want to talk about is, and really kind of tie these ideas, these workflows all together, is how do you manage this? If you've got 30 different features being run in development, and they're being rolled out whenever they are ready, how do you know what is out where? What's on staging? What's on development servers? What's on the production server? Is any given change out there at any point? What's its state of play? What's going on? So this is where I turn this up. Remember I talked about having that magic ticket number that occurs, that we add at the start. And that is used when we create the branch, we tag that ends up in the builds everywhere. So this basically closes the circle. So that ticket number is used by every step along the way, and that means that we can actually feed information back. Now, this is where I'm going to talk a bit about Atlassian specific tools. You can do all of this. Big secret is, not actually that big a secret, is even if you're not using Atlassian tools or only using some Atlassian tools, all of our stuff is just REST APIs. So if you want to actually recreate these workflows and you're using Jenkins and you can't move off it, then you can do that using REST calls. There are ways of doing this. But obviously I'm going to talk a bit about Atlassian's tools because they're paying me to do this stuff, so I probably should talk about them. So this is quite a cool idea. So what you can see here is when you create a branch. So inside we create a ticket inside Jira, and then inside Jira we can press a button that will talk to Bitbucket, and it will get Bitbucket to create the branch, and it will tag that branch with the ticket ID. Then what happens is Bitbucket can then feed that information back into Jira. So in the original ticket, we have this little box off to the side that shows you that, in this case, 3 commits have been made and 1 pull request has been created and it has been merged. So whoever made that original request can see what is happening, or the original developer can, but also the customer. We're very big on openness in the organisation. It's one of our mottos: open company, no bullshit. And this is part of it. The person who raises pull requests, this bug report or feature request, will see the state of play that's going on. This is a really great idea because it means people leave you alone. People don't want good news all the time. They just don't want to be kept in the dark. And if you actually open up the process and let them see what is going on, they'll be much happier, and they'll actually become one of your biggest advocates inside the organisation. Now, so that's part of the feedback, but there are other things. So we can tag things. We have these builds. We're inside Bamboo, it's called deployment environments. Bamboo has the idea that there are multiple places a change can go out to. So in this case, you can see, this is in particular is a development sandbox we're looking at, but it's also a staging environment and production environment, you can see right down the bottom. So Bamboo understands that this change may go out to certain places at different times. These deployment environments are really just boxes for scripts. This is what actually deployment really looks like. You can actually see that if you look on the left-hand side, we download the artifact, in this case being literally the software about to deploy. We do some variable injections. We do a source code checkout. We actually check out our Ansible scripts, and then we do our deploy. So we run Ansible, and we do the deployment, and that will do the deployment out onto the development or production environment. Now, this is great, because this again feeds back into the original ticket. So inside the ticket, we're back at this original ticket now, inside Jira. We can see the little button on the side, you can click and it will show you deployment status. And you can see in this case, the change that has been made here, the commits and the merge pull request, well, all those changes have gone out to the development sandbox. They've also gone out to the staging sandbox. So the original user, they know where the staging sandbox is, and you can just tell them. They go, oh look, it's done. They go off and start checking without even you having to ask. Then when it's ready, you can deploy out to production. But in this case, it's not gone out to production. This gives you this visibility, this very clear one-stop shop for this is the state of play. Now, this works quite well with Jira. You can build this into any tool if you want to. You can use dashboards and so on. There's something called Dashing, which is a Ruby-based system. It's quite nice. You can go and query different systems via REST and build up a dashboard of these are the changes that are currently in play, these are ones been deployed out to production, and so on. But this works in Jira, but it'll work in anything if you're prepared to make the work, do the work. It's a very powerful idea because, as I say, people don't like being kept in the dark. If you show them how to get the information themselves, they'll leave you alone. It's great. People just want you to be treated equally. And this is very much part of the DEVOPS idea. You break down the silos, you give people the information directly and open up your organization, and then they will all help each other. The last thing I want to talk about is a bit of separation of duties, very briefly. One of the problems we had with as moving to a public company in SOX compliance, you must have separation of duties. You must be the person deploying the code must be separate from the person who is writing the code. Now, in our case, we had all these roles. So it's actually something your development environment and your deployment environments and your build systems must have the concept of groups if you're going to work in this environment. You must be able to separate people out. One of the things you can do with the deployment environments in Bamboo is you can say, okay, anyone in a developer group cannot do a deployment. Only people who are in the release group. But then you can set rules that say the release group are never allowed to touch the code inside your Git repository. So you can have this separation of duties based on rules, and that's great because when the auditors come around, and they will, you can then print out all the permissions and say, look, everyone in this group can do this and not this, and everyone in this group can do this and not this, and they go away happy. Or they want a paper trail. That's very important. So you need to bear that in mind if you're working in a regulated environment, which increasingly almost everyone is. So that's coming to the end of the talk. I've covered quite a lot of things quite quickly, I'm afraid. But I'm around for the next 2 days. If you want to ask questions, we'll come and chat. Also, to take away the three main points that I want to get to. You need a clear motivation for why you're going to do continuous deployment. You can't just do it because it's cool. You should do it because you know why you're going to do it, and then you should be able to communicate that to other people in your organization. This is going to affect everyone who interacts with your systems, and increasingly that's pretty much everyone. Branching workflow. You need to be able to separate your work out and only merge it in when it is ready to go out. And you need to have cooperative tools and people. You can't just fudge your way through this. You have to have a very clear idea, be able to look at your systems and go, I know exactly what state they're in. And you also need to be able to have your people cooperating. You need to have your users looking at these changes before they go out. You need to have a fully collaborative system. This is what's supposed to be DevOps at its core. It's not just tools, it's about people communicating at the end of the day. This is the most important idea. So hopefully this helps. I also do a bunch of other talks as well, as part of my new exciting job of going and getting drunk on a regular basis. So actually, you're interested in this sort of things. I do a talk called Understanding Git, which is very useful. It explains some of the low-level ideas behind Git, not just the commands, but why the commands are there. That's quite useful. I do a bit about that continuous integration with Docker. If you are in the Docker environment, I talk about how to do that. But that's pretty much the end of the talk. Hopefully that's been of use. And are there any questions?
Yes, thank you, Steve. Is there any questions for Steve? Maybe have a few minutes time. There you go.
Hey, Kalle here. So, about trunk-based development,
yes.
You are very much talking about branching.
Yes.
Do you have any experience on pre-commit testing and integration that way?
Yes.
Google has,
Yeah, we do. We actually use Subversion up until on this very system for a long time. We're basically committing into the trunk branch on Subversion. First off, can't recommend it. Not best way to do it. There are ways if you are stuck on Subversion. There are tools that you can actually use Git locally, and then there are Git Subversion bridges. Are you using Subversion?
No, I don't. I don't recommend also a Subversion, but trunk-based development on Git,
Oh, okay, yeah. See, the problem there is that all the tools around Git are based on a pull request idea. So this means you do the request before a merge. You're talking about basically doing reviews after a merge occurs, which is if you're doing trunk-based development, there's only one point. Well, one thing is you can actually have separate repositories. You can do forks within GitHub and Bitbucket and so on. You can do a fork and then you get something inspected. There are, if you do want to do sort of post hoc reviews, there are tools out there. The only one that I know, or I have experience with, is ours, which is Fisheye Crucible. We actually did start looking at it as a legacy system. We're actually starting to see an uptake of it. Because there are some things that don't necessarily work well with a pull request-based system. It's great if you're writing code, because you can test code and you can actually prove it correct to some degree before you do the merge. But if you're working on, say, a book, you actually want to do a bunch of commits, and then afterwards go back and review. There is no such thing as right in writing. So Crucible allows you to go back and say, we'll do a bunch of commits because we don't, for some whatever reason, maybe we can't do a branching-based workflow. So you need a tool to actually go back and say, these bunch of commits, I need them to be reviewed and to find a bunch of reviewers. And we do provide a tool for that. There are legitimate reasons for doing that. The other one really is just to be very, very careful. It's very easy in a purely trunk-based system. Subversion is the classic example because you can't do any of the most simplest branch merge tends to break things in our experience. Is you basically you're going to have to go back to a very separate schedule. You need to basically say a bunch of stuff's got committed. This is the last week. You need to go back and review everything and basically make a note of all the changes that are going in. Again, as I say, I don't recommend it for a continuous deployment if you're doing a very fine-grained system. If you'll do continuous deployment and automate it as much as possible, but still have a very big release window, then you really should have some sort of review system in place. GitHub tools like this don't really enable that. Crucible Fisheye does. I think Gerrit might do something like that, as opposed to mock reviews. But yeah, it's basically you are going to be playing with fire because you will be basically put some changes in before you know that they're actually correct. So,
just quick comment on that one. You can test heavily before cloning with the main branch, but okay, let's stop there.
Yeah.
Yes, I think still. Sorry, did you have something more?
No, I was saying any other questions.
I think we need to go on, but you're going to be here 2 days, so.
No, I'm here for the next 2 days, so if you've got any questions or anything, please come and chat.
Okay, thank you one more time.
Thank you.
Okay, now I think it's time to move on, and I'd like to invite the next presentation to at your computer.